Okay, hello everyone. Good morning. So this is Isabel with Wisconsin Land and Water, and thank you for joining us today on, at least where I'm at, a very snowy early Friday morning. As you just heard, I am recording this webinar and it'll be posted on the Wisconsin Land and Water website at some point in the near future. And then I'll be sending everybody who registered a link of that when it's available, as well as a link to our evaluation at the end. So today our presentation will be using APLE-Lots to estimate annual phosphorus and sediment loss from Wisconsin cattle lots. And our presenter is Andrew Craig with Wisconsin DNR. How we're going to do it is that we're going to take questions throughout the presentation through the chat line, which is on that bottom toolbar. And you can submit a question at any time, and we'll try to get them answered throughout or at the end, what flows best. And so I think with that, Andrew, please take it away.
Great, thanks, Isabel. Thanks again for joining today, guys. I see on the participant list, there's some people that are also attended training we did yesterday on PLET and STEPL and using that modeling tool to estimate pollutant loading from gullies and stream banks. PLET also does some, can be used for estimating runoff from feedlots and things like that. I just want to make a clear case here that between those two tools, if you have a question like which one's the best one to use, APLE-Lots is probably a much better modeling tool to use because it's been calibrated to specifically to lots within Wisconsin where edge of field measurements have been collected. Joining us today is Dr. Laura Good from UW Soils in Madison. Laura was one of the principal architects of developing APLE-Lots, as well as Pete Vadas and so forth. In the platform that Isabel put forward, there are some links to the tool, as well as a technical document that explains some of the edge of field research that was done to help calibrate the APLE-Lots tool. So that's been posted there, and she's posting right there too. Thank you, Isabel. The APLE-Lots tool, which I'm going to show you today, I'm going to follow a similar process of showing you how to set up the tool, how to log in, and then go through the steps that it goes through. There's 5 steps you go through to model, identify where the lots are, include the conditions that are occurring on the lots, as well as any contributing areas that may run onto the lots areas, and then finally generate a report which will estimate the pollutant loading to the edge of the lot that you put into this tool, phosphorus loading. It does not, I'm going to make this clear right up front, it does not estimate what's delivered from a lot to surface waters. It's just what is delivered to the edge of the lot area you are entering in the tool. In some cases, the lots that you're modeling may be right next to a stream or a ditch that delivers water to a stream or some other surface water body. In those cases, if it's clearly right next door to a stream, you can assume a majority or nearly all of the pollutants that are shown, that are modeled, will be delivered based on topography and proximity. However, if the lot you're modeling is a quarter mile away and there's no clear defined channel that you can connect the lot to surface waters, it may, this tool and its outputs may not be applicable or useful because there's no direct connection. So those are some of the things I wanted to get out of the way at first. And then in the chat here, there was one question from Jeff Schramm. Jeff, thanks for joining us today. My understanding is Barney is still available. It can be used, but in my understanding, APLE-Lots is a better tool and it's more calibrated to Wisconsin conditions than Barney is. And as far as utilizing along with BERT, it's still possible to use those tools. We're not just crediting them or saying those are no longer applicable. I think we have a better calibrated tool with APLE-Lots than Barney and Bert. So just like yesterday, I'm going to share my screen with you guys. Oh, thanks, Jeff. And walk you through the tool. So let's get started. Okay, so I've already used the link that was included to APLE-Lots. There's a hyperlink here, and I put it in my favorites up here. So I'm just going to click on it up here. And this is after you click on the link, this is what comes up on your screen. And just the way this works here is this navigation up in the upper right corner with this drop-down menu gives you help, the technical document I referred to. If you click on help, and I believe this is going to come up. Isabel, is this showing on the screen? Because yesterday we had a little trouble with that.
Yes, I believe I'm seeing the right thing with the APLE-Lots user notes.
Yep.
Okay, perfect.
So this is like the step-by-step technical guide. We're going to be doing the same thing here. You can refer to this side by side when you're using the tool as well. So just to let you know, that's the case. And what I'll do here is click that off. Okay. So also up here is the technical document I talked to you about. And this is the background of how the model was calibrated with different measurements over time and different types of lots and so on and so forth that Laura Good and Pete Vadas and others were behind and collaborated to produce this tool. So as far as the tool goes, that's this part of the tool. This part over here is what we're going to do next. There's two tabs over here, one called Tools, one called Map Legend. Under the Tools tab, which is activated, there's these steps that we'll be going through. I also, before we start going through this, I want to emphasize the Map Legend here, this is a really cool part of the tool, I think. There are different layers, just like a viewer that you can turn on and off. And these apply, they include base layers, surface water flow layers, groundwater layers, and some farm layers. And some of this, I believe, is carried over from Snap Maps and Snap Plus, the spatial layers that you see here. On the right here is a picture of our state, which you can then start zooming in on, and you can either just click on the map or scroll with your mouse and you can pull it up like I'm doing now. And as you zoom in, it's not super fast, depends on your connection speed and so forth. I'm on a wireless signal here, so this may take a little while to load to get us close. I'm moving into Dane County here and the north end of Lake Mendota, where I'm going to be picking an example farm that I've picked out that I think is a good candidate to demonstrate how this tool can be used. There's also ways to enter in locations by entering township, range, and section or address to zoom in to where you want to go versus just trying to find it visually like I'm doing now in APLE-Lots. So first step one, sign in. And I've got a Google account, so I just use my Google account, which if you haven't done, you can sign in with Google. If you have a Gmail account or something, just enter your username and password with Google and this will link right up. So now I've signed in. And I'm going to zoom in to where this example farm is. It's got to load a little bit here. Getting closer. And the reason I'm zooming in here is because you want to get into kind of a focused area. And then once you get it close enough, you can say, I want to create a project. And here is our example area, which is a lot area with a barn and a paved area, as well as a open dirt exercise area where animals are confined and fed and so forth. And this is used seasonally. And it's taking a while to load, so bear with me here as it gets in. It's not going to be blurry. It'll be very clear as we go forward here. It's just the connection speed. Oh, right on cue. There it is. So for using this tool, you can start just with aerial imagery, but we're assuming here that you may already have done, as a county conservation employee or a consultant or a crop advisor or others, you may have done some on the ground investigation, or at least observing it from the road, perhaps, to see how the lay of the land works and how water may drain from these areas to surface waters. And in this case, there's a, you can see closer here, there's appears to be a channel and culverts that lead to the other side. And there's surface waters that continue to flow into a wetland area over here. Up gradient is some cropland as well. And there's the feed bags and stuff for the animals. If you're unsure about, if you're just using it aerially, you can go back to Map Legend, like I just showed you, and you can use some of these tools to turn on, for example, 2-foot contours, which I'm going to turn on right now. And once you turn this on, these yellow contour lines will appear, or they should in a moment here. And you could better understand, beyond just looking at it from the road or just looking at aerially, how the topography occurs in this area. And they're starting to show up there, which is good. And I'll scroll back here a little bit to give you guys a little more perspective. So clearly, based on the topo lines, this is a higher area, and we're getting lower and lower, and it's concentrating here and going underneath this culvert that way. So we certainly have, based on topography alone, the ability for water to flow into this area and then flow out. Okay, I'll go back to tools now. So if you got your site picked out, or you've kind of done your preliminary work, like I talked about, of trying to see what the connections are here, next step is to create a project, which is right here. So you just click here on the link, and this box comes up saying, okay, what do you want to name your project? I'm going to name it Smith Heifers Lot. I'll just call it Smith Heifers. All right, so you've created the project now, and if you want to, you can, a little bit more about navigation. Once you create a project, it saves it in a library here that shows up, and here's the Smith Heifers, and I've played around with this before. You can click on the various projects you create and open them. You can delete projects from here. And there is a feature where you can share projects with others as well, but I won't go through that right now. So once you've created a project and narrowed down the area that you want to model in APLE-Lots to determine what the runoff loading is from these various areas, you can then continue. Oh, here's the share project function I just mentioned a moment ago. You can go to drawing. You can either go to map list mode or to map mode. Map mode's easier to figure out where everything is, and what we're going to do next is draw some boundaries of where the lot boundaries may be for this area, this example. So now we're going from step 3 to step 4, drawing tools. And there are different tools you can use here to enter in. You can draw a lot boundary or a contributing area to the lot. And as many of you can appreciate, water may be able to flow from an adjacent area. And in this case, with the topography, some of this field definitely can contribute water to this lower lot area where the animals are being housed and fed and so forth. So we'll be drawing both a lot and a contributing area today. Let's draw the lot first. So once you click on draw a lot, this blue circle shows up. And as in the instructions, you click, double click, and a line begins. And I'm kind of drawing the approximate boundary of this lot. And many of you have used tools like this before. This is the technique. Once you draw the lot boundary and connect the lines like I just did, this window comes up. And this is where this tool becomes very powerful and very handy. It automatically calculates the drawn area. You can then name the lot, which I'm doing up here in the upper left corner. I'm just going to call this earth lot because this is the earth area. And as far as square foot area, I'm going to use a similar square foot that's calculated, although it says field verification recommended. That is recommended here. This may not be exact, and I mentioned earlier about maybe doing some field truthing or looking at stuff from the road or talking to the landowner as well. In this case, I'm going to go a little bit short of 69,000 square feet. I'm just going to put in 60,000 that go a little bit under, not being the exact number. Next question you have to answer is, what is the vegetative cover of this lot? This is a little tricky question because depending on the size of year, time of year, it could be vegetated or not vegetated. It also depends on how many animals are confined in this area and the number of animals and how long they're confined in this area on the lot. I live close by this area. I've seen animals in this area multiple times throughout the year, and there's not a lot of vegetative cover because of the number of animals and the time that are there. So I'm going to pick a low number here. I'm just going to say that most of it is dirt, but maybe a percentage is grass. I'm going to pick 20% vegetative cover based on that criteria. Is there a paved area within here? In this earth lot, there is none. So I'm just going to pick 0. There's this other feature about a functioning sediment basin. Does any of this collect in like some type of sediment basin or anything? That's pretty rare, but this feature is applicable. There could be on some farms that may have a functioning sediment basin or a low area where water collects before it leaves the lot. And then finally, days between cleanouts. This is for paved area only. We're not going to apply that to this earth lot. You can say how many days between it's being cleaned out if it's a paved area. Okay, so we got the lot information taken care of here on this dirt lot. Now you can then go to animals. How many animals are on this lot and how often are they there? So I'm going to select, I'm going to add it, instead of copying animals from some other database, I'm going to use this button here. It says add animals to the lot using the calendar. So here we go. When you click on that button, this little calendar shows up. And here you're going to be explaining to APLE-Lots what type of animals are on this area. And I'm just going to pick dairy heifers, 750 pounds, but there's all these different categories, and this is carried over from SNAP Plus and others. So you can customize it if it's a combination of dairy and beef, or dairy and horses, or beef cows and others. So you can pick each of these different categories. For this example, I'll just pick this one. In the month season, with this drop-down menu, you can pick the time frames that align with the menu here. You could either do it month by month, like January, and by clicking on this, you can say how many animals are out there in January when it's frozen and so forth. And in this case, I'm going to pick that there's about 70 dairy heifers at this facility, but they're only out there 1 hour of the day because it's really cold and frozen out there. They may be inside or in a barn during that time. Once you pick these animals and the hours that are available in January, you click Add Animals and it shows up here. Now, instead of doing this you can do this month by month, or you can pick seasonal categories here as well. So if you say, well, this pretty much is the case all through December through March, they're not out here on this outdoor lot, you can click this and remove animals from what I did for January, and you can pick the whole time period for 1 hour, add the animals, and it shows up here, so you don't have to do it 3 times in a row. Okay, so next phase is, let's say we get into the spring, and that's when everything starts melting down, and animals may come out more often, or the lot may be used more often. I'm going to pick this time period, same number of animals, but the time frame of how many hours are out there is going to start to increase. And here you can either do a phased approach, like, okay, they're out there 2 hours a day in April, 6 hours a day in May, and 12 hours a day in June to kind of reflect the vegetation, or it's getting warmer and warmer. Or you can just pick an average, like 4 hours a day, which is what I'm going to pick here just for this example, but you have the option to do this month by month or by seasons. So I'll add the animals. In July and August and September, I'm going to assume that they're not out there at all, that these animals are moved to other areas, and then they are returned in October. And in October, these animals are out there approximately 12 hours a day. In October and November. And then once it gets cold again, everything goes down to 1 hour. So in this example, this may vary based on the site, and it requires some on-the-ground knowledge, but you're able to, the beauty of this part of the tool is you can customize it based on the intensity and the number of animals that may be present or not present during different calendar months of the year to account for the variability of how the lot's used. Once you've got this matched up to where you think this is going on, you can hit close. And then, so we've added animals to this lot. This feature is the next step. If you have some soil test data for this lot, you can add that in here. You just check the box and it'll ask you what the soil test results were. We don't have that in this example. You can also check to see that there's runoff from this to another lot. That's not the case here. If not, you can say what that lot is and so on and so forth, shown there. And finally, if you want to delete the lot, you can delete it, but we don't want to do that. We just want to hit down here. We've entered our data. We've created the lot. Okay. So now, it disappeared. So it didn't work. This didn't happen yesterday, but it did today, as typical during the presentation. So I'll go through these steps real fast. Sorry about the delay here, guys. 20%. I'll add the animals. I'll pick the winter months. 70 animals. And then the spring. And finally, in the fall months. They're not there in the summer. I'll just pick October here. plan for November as well. All right, it worked this time. Thank goodness. Didn't have to make you guys wait any longer. So after you've edited your information for the lot, it says it's been created. So this is what you want to see. If not, you have to go through the steps like I did just a moment ago, but it didn't take that long. So we have this earth lot, and the other thing I wanted to show you here is you can also draw contributing areas, and based on the topography lines here, 2-foot contours, we're going to assume a portion of this. Let me zoom back out here. This is a pretty steep slope field coming down and working its way down here to where the water flows through. A portion of this field is definitely going to be a contributing area. I would not include the entire field, but certainly you can pick a portion of it here. What I'm going to try to do is generally follow the contour lines, and I'm going to be conservative and just go within this area that I'm outlining right now. So to do that, I'm going to draw a contributing area by clicking on the link here. I'm going to go and follow the contour lines like I just explained. And by doing this, you're telling it that this area is contributing to the earth lot runoff or water. So I'm going to say, I'm going to name it contribute area 1. You can do 3, 4, 5, or 6 of these, and I can say very briefly here, in some water quality trading projects where this tool has been used, there's usually multiple fields where there's contributing areas, and then the animals that are allowed to pasture on that field congregate along the stream, and they modeled it in a similar fashion of a high youth intensity area at certain times of the year, and then a contributing area. The square footage here is 120,000 square feet. I'm going to just go 100,000 as a conservative amount. The lot that it contributes to is an earth lot. The contributing area through the drop-down menu here is cropland. There are other options here: grass, woods, farmstead, roofs, and so forth. This is NRCS TR55 table information. That's the runoff category for cropland. Contributing area hydroclass is the final thing you want to go through before hit save. And this is kind of your hydrologic group of the cropland. I'm going to assume this is a silt loam area, so it's hydrologic group B. And finally, there's this added feature. There may be like contour strips or something in the cropland area. This one doesn't have that, but if you click it, you can explain the percent and what the practice is that breaks up the runoff of the contributing area to the lot. But we're not going to do that today because it's not there. So finally, final step, once you got just like the earth lot, you want to save your contributing area, and it shows up there. So, okay, it worked. Fantastic. So what we've modeled here is an earth lot and a contributing area that delivers to the earth lot. There's also this barnyard area, and I won't go through this, but you could, if the animals are confined in this barn and they are on this cement pad area, you could click and create another lot and follow the boundaries, and then explain how often animals are there, what type of seasons and the intensity. And then you could model contributing areas. For example, this side of the barn roof line has no gutters on it, so that you could identify this as a contributing area to this cement lot. However, this other barn does have gutters on it, so you wouldn't include that as a contributing area because it's taking water away from the lot area. So instead of going through all those steps again, the same process, you would just draw a lot, but you'd call this a paved lot and then enter in additional information about that. And This could be used at a different frequency and intensity than the earth lot that we've already done in this example. Okay, so we're getting to the final steps here, the big reveal. So before we get to reports, which is modeling what the loading is from the areas that we've modeled, you can also draw inventory features here on this, because you may want to eventually create a map or something out of it. And this tool allows you to create a map. So you can, for example, say sheet flow direction. You could put in an arrow like this and hit save, and it'll put an arrow in on your map. And you could also do the same here. Is it going to work? There you go. You could also put concentrated flow channels in here. And I'm going to say there's, as the water collects and moves in this area, you can kind of see in the aerial photo that there is a concentrated flow channel that leads to this culvert at this point on here. Once this comes up, a couple of additional features I'll tell you about. You can say what kind of flow channel it is. There's grass waterways, a gully, ephemeral erosion, a ditch, concentrated flow. In this case, I'm going to say it's shallow concentrated flow. Then there's some widths you can do and select here. I'm going to say it's 5 feet wide. It's not that wide of 20 or 30 or something like that. That's pretty rare. Once you've said, here's where a concentrated flow is, you can save the channel, and this big green line shows up on the map. A couple other features I'll show here. You could put an evidence of runoff point right here on the edge of the lot. And I believe that shows up as well. Yep, there's your X. Annotation, I believe you could add some text and things like that as well. So these are some of the other features you can put on the map to kind of better tell the story of what's going on here and how water may be contributing to the lot and what happens when water builds up in the lot and then does it leave and flow off of it. One last thing I'll say back on the map legend here, we turned on the 2-foot contours. There's also surface water layers here, like DNR wetlands that you can turn on and off. And guess what? There's a very large wetland here right across the street. As water goes under this culvert, it flows into the wetland. You can also turn on, for example, perennial streams and intermittent streams, which I'm clicking on right now. And this tells a very important story of how there may be areas that this is historically an intermittent stream channel that water has flowed through, and then it's available to be shown on the map. As you go further out, you can see where this goes from an intermittent to a perennial unnamed tributary, and this tributary goes all the way to the Ohio River and Lake Mendota. Definite connection to surface water, which is why I picked this example. You can also turn on watershed boundaries, and there's some other features you can turn on, impaired water layers. There's some groundwater layers you can turn on about if this may not be going to surface waters, but if you're in an area with shallow fractured bedrock and this runoff leads to a area where bedrock's very shallow, or there may be a swallet or some fractured rock area and the water goes straight down to the aquifer, or the ability to get into the cracks that lead to an aquifer, you could use these features to get at the risk of this site for contaminating groundwater, this lot. And then there's farm layers here as well. Okay, so back to tools. I'm going to click on the tools tab. just want to walk you through the features. We're at the final step. The big reveal is the reports. So I'm going to click reports, and these two options come up. One is called create a report, which is what you want to do. The other is to create a PDF of this area that you've worked on and modeled. And by clicking on this, it just creates a PDF of the map that shows up. And then you can include that map with your report, which I'm going to click on right now. So once you click on report, this window comes up and it says, select a lot to create a report for. And if you've got multiple lots, you got to tell it which one you want to create the report for. We only have one in this case, so that's fine. And I'll say, you got to name it. I'll say earth lot runoff is the name of the report. I'll say, if you want to put the name in there, you can. It's up to you. In my example, I said Smith Heathers as the project name. And then you hit create the report. So here, when you do this, a Excel spreadsheet shows up here, and I'm going to have to stop sharing because it's a new window that comes up in this presentation. I got to stop sharing and then reshare when the Excel spreadsheet's available. So just a second. Excel spreadsheet's coming up, and I'm going to come back here and reshare my screen. See if I can find you guys here. There we go. Okay, sorry for the delay. Just the presentation. Can you guys see this Excel spreadsheet now, the report?
Yes, we can.
Great. Okay. Got better than yesterday. Yesterday, I had a little trouble with this, but my practice makes me perfect here. All right. So this is the report. This is the project name. I'll just kind of walk you through what the results show. It's for this earth lot. It kind of gives you an idea of the county and the general location and some of the inputs you put into it. This is summarizes it all and gets into what's the size of the area of the dirt lot, the contributing area, what the contributing area consists of, and then finally, how often animals are present on the lot through the calendar year. And then finally, this is what we're trying to get at is like, okay, what's going on in the lot and what is the amount of phosphorus delivered to the edge of the lot, which in the map showed there it discharges at the point right to a culvert. Here's your results, 124 pounds. So it's kind of like those of you that have used Barney and things like that, it's kind of a similar setup, but there's much more specific flexibility about how you want to capture what's going on in the lot, the contributing areas, and the outputs are based upon actual edge of field lot research that match up with what type of lot you're putting in, dirt lots, paved lots, for example, and how those lots are used. So this tool is much more calibrated to Wisconsin conditions, and you could then include this report with the map and say, here's what we have identified as the current loading. And then after implementing a series of practices, you may reduce the loading, or you may, by reducing how often animals are out here at certain times or increasing vegetation, you could do a pre-post comparison that way. Or you could say, the easiest solution is just to move the animals off this entirely. We're going to move them to another area where there isn't this connection to surface waters. And your full reduction would be, if this becomes completely vegetated and no longer used by animals, your reduction would be 124 pounds because it's fully vegetated. So those are some examples of, I'm going to stop sharing now and go back to the tool here. Last part, I've showed you the report. You can create a PDF of the map. And you could do portrait or landscape layout. It says it works better in landscape. You can do legend on a separate page or on the same page. We're just going to put it on the same page. Here's what happens when you create the map. This shows up. And Isabel, can you see the map that I just created, or do I need to stop sharing and reshare?
I currently see the Smith Heifers.pdf map. Let's see.
Does it say Smith Heifers generated 12/9/2022? Okay, you can see that. Great. All right.
Perfect.
So here's your map and showing the same thing, but it's captured on a PDF map. So you could combine this with the Excel spreadsheet. So the way this tool's set up, it's kind of user friendly to create these type of maps and reports. And more importantly, it's pretty well calibrated to reflect what's going on based on actual edge of lot measurements, what is being delivered from these areas to the edge of the lot. And if there's a direct connection to surface water, which is the example I showed here, you could assume a majority or all of that is being lost annually in terms of pounds of phosphorus to surface waters. And that becomes your baseline to measure against for adding BMPs to reduce or eliminate that loading. Okay, that is APLE-Lots, everyone. Is there any questions people would like to ask based on the steps I just went through, or do you want to see something new or different? I have time here to answer your questions. We're about 45 minutes in. Yeah, go ahead.
Just was wondering why there's not a clean out time for earthen lots.
Right. My understanding is that when this was developed, it was assumed that those earthen lots were not cleaned out in any way, or you could call it a paved lot and then explain it that it's not, even though it's paved, you could say it's cleaned out, even though it's not paved, you could capture the clean out at that point. Laura,
Okay.
do you have anything to say about that? Because Laura Good's with us today. She might be able to answer that question better than I just did.
When we were working on it, our technical advisory group considered that question, and the general their general idea was that if they scraped it out, it wouldn't be often enough or complete enough to make it have the same mechanism that we use for the paved lots, which is that it all gets moved off the lot every time that it gets cleaned.
Okay. One more question, Andrew. Is there a way to go back and edit information such as maybe the size of the animals on the lot? Because I've been trying to do that. I can't seem to figure that out. If I entered the wrong numbers, for example, can I go back and do that, or do I have to start over again?
I believe you are muted, Andrew.
Sorry, my understanding is you can edit both the types of animals and how often they're out there, as well as the lot dimensions and conditions as well. They're all editable. It sounds like you're still having some trouble though.
Yeah, I just wanted to change the timeout or the clean out period on the lot, and for some reason I can't seem to get into that portion, but maybe that's just operator error.
It might be. None of these tools are perfect. They all have little quirks and bugs with them. But it's often, if you use them more frequently, you can get better and better at using them. And sometimes you learn from your mistakes too. I mean, it may be order of operations, or you may be picking from the wrong drop-down menu or something like that. Are there any other questions from the audience, or things you guys would like to see? I don't know. I don't think we need to do the whole 2 hours here, but we can definitely proceed for another 10 or 15 minutes if there's interest.
Yeah, Andrew, Mitch McCarthy here. So you mentioned that, it's just for right at the edge of the lot. By the way, great modeling tool. Seems pretty straightforward, user-friendly. And then which additional modeling tool would you recommend using for once we get, off the lot, to model best management practices?
So Mitch, your question is, that was Mitch McCarthy, right? If the lot doesn't have a direct connection to surface waters, is there another tool that could estimate the delivery or the fraction that may be getting the surface waters if it's not right next to a stream? Is that your question?
Yeah. Would you then do, Barney in addition to it to model that filter strip, or, if you actually do a barnyard containment project, you wouldn't quite have a zero reduction potentially. There's always things that do run off. So kind of which companion tool would you kind of do with it as well?
Yeah, I don't think there's one right answer here, Mitch. In estimating delivery, it's really one of the most difficult things to do, and that's why I led with some of the disclaimers at the start of this training that this tool is best to use where it's right next to surface waters, or a short distance where there's a clear concentrated flow channel. And with that direct connection made, you can assume all or a very high percentage of what's being delivered to the edge of the lot is continued from the edge of the lot to surface waters. But the further you get away, a proportion of that percentage of that may only be delivered. I can definitely say you can consult with us at DNR, and it could be jointly discussed about what the right percentage number could be. Another recommendation I can provide here would be to use something along the same lines as the trade ratios, which we've used in water quality trading, which basically says the further you get away from the location of the lot to surface waters, there's more and more uncertainty about what amount may be delivered. So in water quality trading, we account for uncertainty with certain models like SNAP Plus calculations for cropland phosphorus losses. When cropland practices are used to reduce that loading, we apply what are called trade ratios, which is basically dividing the total mass of phosphorus by 2, 3, or 4. And basically by doing the division that way, you're accounting for some of the uncertainty, and you're reducing the amount of phosphorus that actually may be delivered. Any other questions from the audience or follow-up questions? You guys want to see anything else? You want me to go back to the example and try to manipulate some things or adjust stuff? I can do that too today if you'd like, or you can go to this tool yourself and create either an example area to kind of get used to the navigation and the steps, and try it out. Yesterday I did a 1-hour dry run of this area that I showed you today. Took me about an hour and things worked fine. So you can do the same on your own. I guess I'll say, if there's no other questions, I'll make one other comment about the pollutant load estimation tool. I kind of alluded to this yesterday. There is a feature in PLET where you can model feedlots and you enter certain information to account for the conditions on the lot, like APLE-Lots does, but it's pretty general, and it has some predefined what type of pollutant concentrations may come off that lot, whether it's paved or unpaved, and how many animals are on it, and so forth. APLE-Lots is much more refined in based on the research. We do have a question here from Tina. Thanks, Tina. How do you suggest using total P loss to determine what to do with lot? So I guess, are you saying this? Oh, okay. Thanks for the clarification. So yeah, if this could be used as a prioritization tool. So let's say you have multiple lots that you're aware of, and you have limited time or resources, financial resources, staff time resources, to make contact with the landowner or offer grants or loans or other things to try to address this area. So you could use this tool to kind of estimate the loading of individual lots and rank them accordingly. In some watershed-based plans, that's exactly what has been done, where there's been an inventory of multiple feedlots, in some cases dozens and dozens of them. They've estimated their loading using Barney, and in one case they did use APLE-Lots, and they ranked them accordingly. And they said, we only think we can address in this time period 3 of the top 10 loading lots that we've evaluated based on our time and our resources available. Another follow-up is, yeah, Tina, you're correct. They're all resources concerns if they discharge directly to surface waters. That's the position we have at DNR, and I think in many cases others would be as well. But then the next question is how, if there's loading of pollutants as a direct discharge, that gets into the 151 performance standards, which says you can't have a direct discharge from a lot to surface waters. That 151 standard would apply. All right, we got some other questions here. Terry Kafka from DNR would like me to go back and install a clean water diversion by removing the contributing area to the earthen lot. I can go do that in a second, Terry, hang on. And then Tina did a follow-up question. So any P loss is direct runoff. Well, APLE-Lots is estimating the amount of phosphorus that's being generated by the lot and delivered to the lot edge. And then the question is, does what's leaving the lot edge reach surface waters? And that, if it does, then it's direct runoff to surface waters. That's the test or the connection you need to make. And that could be done by field verification or a combination of that and using topography and aerial imagery like I showed today. So I can definitely remove the contributing area right now. I'll do that right now. Hang on a second. All right, can everybody see the working feature here? Or do I need to reshare my screen?
I believe we can see it. I can see the APLE-Lots right now.
Okay, perfect. Okay. So if we want to say, like Terry's suggesting, let's eliminate the contributing area through routing the water around the lot, the runoff area, you can go to editing tools and you can either delete a feature or edit an inventory feature. And edit, you can, I'm sorry, let's see, edit a model input feature. So you can edit lots or contributing areas. So you can change these, like let's say you don't get all of it, but some of it, or you can just say, we're gonna put in a diversion around this entirely so none of this water contributing area gets there. You would then delete the contributing area. So you can do delete a model feature and you can delete the contributing area. And then it says here, this is what's selected now. And it says you can do more than one if you want. I'm going to delete it. It says, you sure you want to do this? Okay, here we go. It's gone. You could then delete these features too by editing the inventory features as well, or drawing tools as well. Like this. Should be one of these. Okay. So that's that. So if this is eliminated, I'm sure Terry and others want to see, okay, how much does this reduce? We had 125 pounds before. Now that it's gone, it's just what's leaving this lot from just the lot area. We can click reports, create a report. Earth lot, no contrib area is what I'll call it. And create your report. This PDF, I'm sorry, Excel spreadsheet shows up here in the lower left corner. I'm going to click on that. And can anybody see the Excel spreadsheet, or do I have to stop sharing and reshare right now?
We cannot see the Excel spreadsheet.
Okay, I will reshare just a minute. Here we go. Can you see it now?
Yes, we can.
Thank you. So this is the revised report, or report number 2, without the contributing area, but still we got the same animals and time frames. And we went from 124 pounds to 85 pounds. So thanks, Terry, for asking that example. That alone could be a way to say we reduced, just by this, we didn't stop the runoff, but we did reduce how much loading of phosphorus is leaving the lot through just that one practice. That would be 25, well, 15 pounds and then 25, so 40 pound reduction roughly. Okay, and you can rinse, recycle, repeat these same kind of steps on your own if you like to see what the type of changes could occur. For example, if you eliminated or how often animals, or the number of animals on that area, or increase the vegetated area because less animals are out there, you can turn those knobs or flip those switches to see what the resulting reductions are from your baseline. As you create these Excel spreadsheets, save them. You can save them to your computer, name them and so forth, and put it in a common folder. Like I created this example, Smith heifers. You could start parking it in there, and you could name each one and then contrast and compare. Any other questions from the audience today? Or hopefully you guys have a much better idea of how this tool works, how to navigate through it, how to create reports and contrast and compare. It can be a very valuable tool, not only for documenting how you're implementing, if you're a county employee, your land water plan and meeting some of those objectives. If you're working in a watershed-based planning area, helping implement a TMDL, or going as far as a very detailed exact point, a water quality trade. This tool could fit in all those situations.
Okay, well, I'm not hearing or seeing any other questions yet. So I am going to stop this recording.